Okay, then electrocyclic reaction mechanism. The mechanism of electrocyclic reaction is explained by Frontier molecular orbital approach. For example, consider 1,3-butadiene under thermal or photochemical condition. What happens? Here pi electrons undergo shifting and to form a four-membered cyclic compound. So here one of the pi bond is converted into a sigma bond, and this is the newly formed sigma bond. Newly formed sigma bond. And my question, how this sigma bond is formed? This is the newly formed sigma bond between, this is carbon number 1, carbon number 2, carbon number 3, carbon number 4. A new sigma bond is formed between carbon 1 and 4. A new sigma bond is formed between carbon 1 and 4. How? That is explained by Frontier molecular orbital approach. First of all, I will explain the conventional mechanism. After that, I will give you a short trick for your CSIR NET exam. Okay. First of all, I will explain the conventional Frontier molecular orbital approach, that mechanism. After that, I will give you a short trick. Okay. So, how this sigma bond is formed? How this sigma bond is formed? That is our question. And it is explained by Frontier molecular orbital approach. Frontier molecular orbital approach. So the first system I am explaining is 4n system. 4n system. What is a typical example for a 4n system? 1,3-butadiene. 1,3-butadiene is a typical 4n system. Okay. So the first system that I am going to explain is 4n system by FMO approach. According to FMO approach, number of molecular orbitals equal to number of pi bonded carbon atoms. Number of pi bonded carbon atoms. So how many molecular orbitals are there? Number of molecular orbitals equal to number of pi bonded carbon atoms. So in cyclobutadiene, how many pi bonded carbon atoms are there? 1, 2, 3, 4. 4 pi bonded carbon atoms are there. So 4 molecular orbitals are there for cyclobutadiene. So the first one, this is the cyclobutadiene molecule. This is the cyclobutadiene molecule. Since 4 pi bonds are there, definitely cyclobutadiene have 4 molecular orbitals. Cyclobutadiene having 4 molecular orbitals, and they are represented as carbon number 1, carbon number 2, carbon number 3, carbon number 4. 4 carbon, like that. Okay. Okay, this is the first molecular orbital psi1, second molecular orbital psi2, third molecular orbital psi3, and fourth molecular orbital psi4. So how many molecular orbitals are there? 4 molecular orbitals are there. Psi1, psi2, psi3, psi4. Psi1, psi2, psi3, psi4. Number of molecular orbitals equal to number of pi bonded carbon atom. Then what is the sign of each molecular orbital? What is the sign? What is the sign of each molecular orbital? Plus, 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 minus, minus, plus, minus, minus, plus, plus minus plus minus. This is the sign. Plus 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 minus minus plus minus minus plus plus minus plus minus. Okay, so once again, what is the sign of psi 1? For having plus 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 minus minus plus minus minus plus plus minus plus minus. Okay, this was one of the previous question of CSIR NET exam. What is the sign of these molecular orbitals? I think in June 2017. June 2017. Okay. So psi 1, psi 2, psi 3, psi 4. So in butadiene, 4 molecular orbitals are there, namely psi 1, psi 2, psi 3, psi 4. The sign of the molecular orbitals plus 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 minus minus plus minus minus plus plus minus plus minus. Okay, as here the interaction is between plus and plus, plus and plus. Here the interaction is between plus and plus. Here the interaction is between plus and plus. So 3 interactions are there, plus 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 plus. Interaction between same phase results in bonding. Interaction between opposite phases results in anti-bonding. So how many bonding interaction? Plus plus 1, plus plus 2, plus plus 3. So 3 bonding interaction and 0 anti-bonding interaction in psi 1. In psi 1, 3 bonding interaction and 0 anti-bonding interaction. What about the psi 2? Plus plus bonding, minus minus bonding, plus minus is anti-bonding. So here 0 anti-bonding, in psi 2 1 anti-bonding, in psi 3 2 anti-bonding, in psi 4 3 anti-bonding. Then what about the bonding? Here 1 2 bonding, 2 bonding, 1 anti-bonding. Here minus minus 1 bonding, 2 anti-bonding, plus minus anti-bonding, plus minus anti-bonding, plus minus anti-bonding. Here 0 bonding. Then what about the bonding and anti-bonding interactions in psi 1, psi 2, psi 3, psi 4? In psi 1, 3 bonding interaction and 0 anti-bonding interaction. In psi 2, 2 bonding interaction and 1 anti-bonding interaction. In psi 3, 1 bonding interaction and 2 anti-bonding interaction. In psi 4, 0 bonding interaction and 3 anti-bonding interaction. Okay, so there are total 4 molecular orbitals are there. This is the first molecular orbital psi 1, second molecular orbital psi 2, third molecular orbital psi 3, fourth molecular orbital psi 4. Fourth molecular orbital psi 4. So under thermal condition is thermal, under thermal condition. So total how many pi electrons are there in butadiene? Total how many pi electrons? 2 plus 2, 4 pi electrons are there in butadiene, and these 4 pi electrons are arranged like this: 1, 2, 3, 4. Under thermal condition, the 4 pi electrons are arranged in this manner. In thermal condition, there is no excitation because thermal energy is not sufficient to excite the electron. So under thermal condition, 2, 4 electrons. Then what is the HOMO and what is the LUMO? Under thermal condition, our HOMO is psi 2. Psi 2 is the HOMO. Psi 2 is the HOMO. Under thermal condition, psi 2 is the HOMO. That means what is the sign of psi 2? Plus plus minus minus. Plus plus minus minus. Then you are giving photochemical condition. H nu. Light is irradiated. That means photochemical condition. Photochemical condition. Light is irradiated. Photochemical condition. Under photochemical condition, excitation of electron takes place. These are the 4 molecular orbitals: psi 1, psi 2, psi 3, psi 4. Under photochemical condition, what happens? One of the electrons in psi 2 is excited to psi 3. So the electronic arrangement under photochemical condition: 1, 2, 3, 4. So here what is the HOMO? What is the HOMO? Here psi 3 is the HOMO. Psi 3 is the HOMO. Psi 3 is the HOMO. Okay. So in 1,3-butadiene, Under thermal condition, Site 2 is the HOMO, because thermal condition electrons is arranged as like Pauli's exclusion principle. There is no excitation of electron. 2, 4 electrons are arranged like this. But when you irradiate it with the light, under photochemical condition, one of the electron is excited to the next molecular orbital, Site 3. So in for thermal condition, Site 2 is the HOMO and Site 3 is the LUMO. Under photochemical condition, Site 3 is the HOMO and Site 4 is the LUMO. Clear? Clear? So make a note. Make a note. In foreign system, or in 1,3-butadiene, Site 2 is the HOMO. In 1,3-butadiene, Site 2 is the HOMO in thermal condition and Site 3 is the HOMO in photochemical condition. Clear? Based on that, I will explain how the new sigma bond is formed. Based on that, I will explain how the new sigma bond is formed. So please listen. So first one, thermal condition. Thermal condition. The HOMO. Thermal condition. HOMO. Explain the HOMO. In thermal condition. In thermal condition, HOMO is Site 2. HOMO is Site 2. Site 2 is the HOMO. This is 1,3-butadiene, a foreign system, and Site 2 is the HOMO. Okay, what about the sign? What about the sign of Site 2? Plus, plus, minus, minus. Upper lobe is plus, then lower lobe is minus, minus, plus, plus. Okay. So, new bond is formed between carbon 1 and carbon 4. New bond is formed between carbon 1 and carbon 4. This is the carbon 1 and this is the carbon 4. The overlapping orbitals must have same sign. The overlapping orbitals must have same sign. So here new bond between carbon 1 and carbon 4. This is our first carbon and this is our fourth carbon. So carbon 1 and carbon 4 makes a sigma bond. The overlapping orbitals must have same sign. That is our condition. The overlapping orbitals must have same sign. So here this lobe is having positive sign. So this will overlap with the positive lobe of the fourth carbon. Okay. So here in the first carbon, this positive lobe will overlap with the positive lobe of the fourth carbon. Then only a bond is formed. A bond is formed between overlapping of same phase orbitals. Okay. So for that overlap, I am rotating this first carbon clockwise. So rotating, we have to discuss only about the first and fourth carbon. So this first carbon is rotated clockwise. Then rotating clockwise. This is positive, this is negative. So in order to make the bond formation, this carbon will be rotated like this. So the fourth carbon is also rotated clockwise. Clockwise rotation. What happens? This is the fourth carbon. This is plus, minus. Okay. First carbon, this is the rotating center. This is the rotating center. I am rotating the first carbon, that become positive, negative. Second carbon also rotating clockwise, positive, negative. So here overlapping takes place. Here between these two overlapping takes place and a new bond is formed. So here both rotation are in clockwise. First carbon clockwise, second carbon also clockwise. That rotation is called cone rotation. That is called cone rotation. So what is cone rotation? If both rotation, cone rotation means if both rotation are in clockwise or both rotation are in anti-clockwise. These two are called cone rotation. Cone rotation. Okay. If one in clockwise, other in anti-clockwise. If first in anti-clockwise or second in clockwise. If one rotation in clock and other rotation in clock, that is called disrotation. So in pericyclic reaction, two types of rotations are there. Cone rotation and disrotation. What is cone rotation? If both rotation are in both rotation clock or anti-clock, then cone. One clock, one anti-clock, that is called disrotation. So here for the bond formation, what type of rotation is required? What type of rotation is required? Cone rotation is required. Okay. So foreign system, thermal condition for bond formation, cone rotation. That is the summary. We will sum up. Okay. Foreign system under thermal condition, in order to make the bond formation, what type of rotation? Cone rotation. What is cone rotation? Both rotation. This is the rotating center. This is the rotating center. This is the rotating center. If both rotations are clock or both rotations are anti-clock, this is called cone. If one clock and other anti-clock, then it's called disrotation. Okay. So what is the summary? What is the summary? What is the summary? Foreign system, thermal condition for bond formation, cone rotation. Very, very important point. Finally, I will give you a chart. Foreign thermal cone. Foreign thermal cone. Foreign thermal cone. Now we have to discuss about the photochemical condition. So B, photochemical condition. Photochemical. So under photochemical condition, psi 3 is the HOMO. Under photochemical condition, our HOMO is psi 3. Okay, psi 3 is the HOMO. We have to think about the first and fourth carbon. This is the first carbon and this is the fourth carbon. What is the sign of psi 3? Plus, plus, minus, minus, plus. Okay, plus, 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 minus, minus, plus, minus, minus, plus. Okay. So, new bond formed between C1 and C4. C1 and C4. So, in order to make the bond formation, both orbitals, both overlapping orbitals must have same sign. So, I am rotating the first one clockwise. This is the rotating center. So, rotating first one clockwise. Clockwise. Rotating the first one clockwise. So this is plus and this is minus. After clockwise rotation, here plus, here minus. So for overlapping, the positive lobe will overlap with the positive overlap. So here what type of rotation? Anti-clockwise rotation. Here anti-clockwise rotation is required. This is the rotating center. Anti-clockwise rotation is required. So this is plus and this is minus. Plus and minus. So same phase overlap takes place. New bond is formed. So here one rotation in clock, other rotation in anti-clock. Okay, first carbon rotation clockwise, second carbon rotation anti-clock for the favorable bond formation. So that type of rotation is called as disrotation. That type of rotation is called as what? Disrotation. Disrotation. So you can conclude that foreign system under photochemical condition, disrotation. This is our summary. You have to study this result only, but you have to memorize the sign of the orbitals, sign of the 4 molecular orbitals, plus, 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 that we will study in quantum mechanics. Okay. Okay, foreign thermal foreign thermal cone, foreign photochemical disrotation. That is the result. So in order to make the bond formation, in order for the bond formation, what type of rotation is required? Disrotation is required. So foreign thermal cone and foreign photochemical dis. Okay. So next, foreign plus 2 system. Foreign plus 2 system. Mechanism of foreign plus 2 system. What is an example for a foreign plus 2 system? Foreign plus 2 system. This is a typical example for a foreign system under thermal or photochemical condition. What about the electron shift? So here a new bond is formed between first and sixth carbon. So the product is, this is the product, and new sigma bond is formed between first and sixth carbon. So how many pi bonded carbon atoms are there? 1, 2, 3, 4, 5, 6. 6 pi bonded carbon atoms are there. So definitely 6 molecular orbitals are there. The 6 molecular orbitals can be represented like this. 1, 2, 3, 4, 5, 6. 6 carbon. Okay, these are the 6 molecular orbitals. You can expect a question based on the sign of this 6MO in future CSIR exam, because 1,3-butadiene is asked in June 2017. So in future exam you can expect a question based on 1,3,5-hexatriene. Okay, this is psi 1, psi 2, psi 3, psi 4, psi 5, psi 6. 6 molecular orbitals are there. 6 molecular orbitals are there. We have to think about the first and sixth carbon, because new bond is formed between the first and sixth carbon. Okay, new bond is formed between the first and sixth carbon. So you have to think about the first and sign of the first and sixth carbon. The sign is like this: psi 1 plus plus, plus minus, plus plus, plus minus, plus plus, plus minus. This is the sign of first and sixth carbon. Plus plus, plus minus, plus plus, plus minus, plus plus, plus minus. Okay. So Psi1 both plus. Psi1 both plus. Psi2 plus minus. Plus minus. Psi3 plus plus. Psi4 plus minus. Psi5 plus plus. Psi6 plus minus. Okay. So that is the sign of the 6 molecular orbitals. Very, very important. Give a star mark. You can expect a question. Okay. Then then how many molecular orbitals are there? 6 molecular orbitals. 1, 2, 3, 4, 5, 6. Total 6 molecular orbitals are there. Under thermal condition, condition is thermal condition. What is the arrangement of 2, 4, 6? This is a 4n plus 2 system. 6 pi electrons are there. They are arranged as 1, 2, 3, 4, 5, 6. The 6 pi electrons are arranged like this. Then under photochemical condition, what happens? Excitation of electron. So under photochemical condition, what is the arrangement of electron? The 6 molecular orbitals in photochemical condition 1, 2, 3, 4, 5, 6. One of the electron from Psi3 is excited to Psi4. So in thermal condition, Psi3 is the HOMO. In thermal condition, Psi3 is the HOMO. And in photochemical condition, Psi4 is the HOMO. Okay, in thermal condition Psi3 is the HOMO and in photochemical condition Psi4 is the HOMO. Clear? That is our key point. In 1,3-butadiene thermal condition Psi2 is the HOMO, photochemical condition Psi3 is the HOMO. So here thermal condition Psi3 is the HOMO and in photochemical condition Psi4 is the HOMO. Okay, very important. Thermal condition Psi3 is the HOMO. You can expect a 2-mark question based on this also. Okay, under thermal condition excitation of electron does not take place because thermal energy is only 3/2 kBt. That energy is very not sufficient to excite the electron. Okay, 3/2 kBt. Okay, so thermal Psi3 is the HOMO, photochemical Psi4 is the HOMO. What is the sign of Psi1, Psi2, Psi3? Carbon 1 and 6 plus 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 minus plus 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 minus plus 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 minus. Okay, so we can explain the mechanism how the new bond is formed between carbon 1 and carbon 6 in a 4n plus 2 system. How the new bond is formed. Okay, so first one 4n plus 2 system. Thermal condition HOMO is Psi3. Psi3 is the HOMO. 4n plus 2 system, thermal condition Psi3 is the HOMO. So I can represent the Psi3. Only represent the first and sixth carbon. This is the first carbon and this is the sixth carbon. New bond is formed between first and sixth carbon. What is the sign? Plus plus, plus minus, plus plus. Psi3 is plus plus. Okay, Psi1 plus plus, Psi2 plus minus, plus plus, plus minus, plus plus, plus minus. Psi1, Psi2, Psi3, Psi4, Psi6. So Psi3 is plus plus. So this is minus. So new bond formed between C1 and C6. For bond formation, the overlapping orbitals must be in same phase. So I am rotating the first carbon. Clockwise. Rotating the first carbon clockwise. So what happens? First carbon is rotated in clockwise direction. So this is plus, this is minus. So for bond formation, second carbon must be rotated in anti-clockwise direction. Then only this positive will overlap with that positive. If clockwise rotation, plus and minus comes together. So here sixth carbon is rotated anti-clockwise rotation. So here overlapping takes place. This is plus and this is minus. A new bond is formed. So what type of rotation is here? First one clock, sixth one anti-clock. So clock and anti-clock, that type of rotation is called disrotation. That type of rotation is called as what? Disrotation. That type of rotation is called. So we can conclude for a 4n+2 system under thermal condition, disrotation. 4n thermal cone. 4n thermal cone. 4n+2 thermal dis. Okay. 4n+2 thermal dis. Okay. Next system. 4n+2 photochemical. 4n+2 photochemical. Psi4 is the HOMO. HOMO is Psi4. HOMO is Psi4. So represent the Psi4 orbit. Psi4. This is the first carbon and this is the fourth carbon. What about the sign? Sign Psi4. Psi4 is Psi1, Psi2, Psi4 is plus minus. Plus minus. So bond formed between C1 and C6. Sorry, it's bond formed between C1 and C6. So rotating the first carbon in clockwise direction. I am rotating the first carbon clockwise. Rotating the first carbon clockwise. So after clockwise rotation, here plus, here minus. Plus, minus. So for bond formation, what type of rotation that I have to perform in the sixth carbon? For bond formation, what type of rotation that I have to perform in the sixth carbon? Here positive is towards there. So in order to become positive overlap, I am rotating the sixth carbon also clockwise. Sixth carbon also clockwise. After clockwise rotation, positive comes here. So this carbon also clockwise. So positive, negative. Positive, negative. So both carbon clock, that is called as cone rotation. That is called as cone rotation. So what is the summary? How we can sum up? 4n+2 system. 4n+2 system under photochemical condition, cone rotation. 4n+2 system, photochemical condition, cone rotation. So that's about the mechanism of electrocyclic reaction. We have a short trick. You have to study the short trick only, but study the sign of the molecular orbitals, because you can expect a question, and that was also a previous question. Okay, that's why I explained the complete mechanism. So short trick. For the summary, okay, for selection rules. Selection rules. Same selection rule is used for electrocyclic ring opening, and ring closure. Same selection rule is used for electrocyclic ring opening and ring closure. So this is our summary system, under thermal condition, under photochemical condition. Okay, system, thermal condition, photochemical condition. If your system is foreign system, thermal condition, what type of rotation? Cone rotation. Foreign thermal cone. That's the only thing that you have to memorize. Okay, foreign thermal cone. Okay, foreign thermal cone. Then photochemical disk. Photochemical disk. Then what about the 4n+2 system? 4n+2 thermal disk. This is cone. Okay, so give a star mark. This is the only thing that you have to memorize. Foreign thermal cone, foreign photochemical disk, 4n+2 thermal disk, 4n+2 thermal cone. Just study one thing, foreign thermal cone. Then other you can express based on that. Foreign thermal cone, then foreign photochemical disk, then 4n+2 thermal disk, 4n+2 photochemical cone. Okay, so that is the selection rule or the short trick. You can predict what type of rotation that I have to perform for the bond formation. What type of rotation that I have to perform for the bond formation. Okay, that is the mechanism of pericyclic or electrocyclic reaction. Okay, moving to some question. First question. Thermal condition. What is the product? What is the product? This is a foreign system. Substituted 1,3-butadiene. Okay. So after electrocyclization, you will get a product like this. So 1, 2, 3, 4. A 4-membered ring is the product. A 4-membered ring is the product. A new sigma bond is formed between 1 and 4. So here a pi bond is there, a pi bond. So my question, what is the stereochemistry of these two methyl groups? What is the stereochemistry of that two methyl groups? Okay, so your system is a foreign system. System is a foreign system. Condition is thermal. What type of rotation? What type of rotation? Foreign thermal cone. Foreign thermal cone rotation. So this is the rotating center. This is the rotating center. Okay, so cone rotation means both clock or both anti-clock. Okay, so this is cone rotation. So I am rotating first carbon clockwise, fourth carbon also clockwise. So clock. So after rotation, this CH3 is above the plane. After rotation, this CH3 is above the plane. After rotation, this CH3 is below the plane. Clear? I am performing cone rotation. After clockwise rotation, this CH3 goes above the plane. After rotation, this CH3 goes below the plane. So both are opposite. Okay. So one CH3 is above the plane. One CH3 is above the plane. Solid line, and the other CH3 is below the plane. So both are trans to each other. Both are trans to each other. Okay. So one of the methyl group above the plane by solid wedge and other is below the plane by dash. Okay, so that is the stereochemistry of that reaction. Same reaction under photochemical condition. What is the stereochemistry of the product? Same reaction. Under photochemical condition. You know what is a product formed here? Electrocyclization, because this is a conjugated polyene. Electrocyclization takes place and you will get a 4-membered ring. You will get a 4-membered ring, here a double bond. You have to explain the stereochemistry of these two methyl groups. So here system is foreign, photochemical condition, rotation is disrotation. Rotation is disrotation. Disrotation means first carbon clockwise, fourth carbon anti-clock. Fourth carbon anti-clock. So clockwise rotation of first carbon, CH3 above. Anti-clockwise rotation of fourth carbon, CH3 above. So both CH3 above. both CH3 above the plane. This is the first CH3 above the plane. This is the fourth CH3 above the plane. So both are on same plane. So the product is cis. The product is cis product. Product is cis product. Okay. Then next question. Third one. Condition, thermal condition. Condition is thermal condition. Okay. So what is the system? Foreign system. Foreign thermal. What type of rotation that you have to perform? Cone rotation. This is the rotating center. Rotating center. So cone rotation. First carbon clock, fourth carbon also clock. So after clockwise rotation, this CH3 is below the plane. This CH3 is also below the plane. Okay. So after clockwise rotation, what happens? After clockwise rotation, first CH3 is below the plane. Fourth CH3 is also below the plane. So you will get what is the stereochemistry. First of all, cyclization takes place to form a 4-membered ring. What is the stereochemistry of these two methyl groups? Stereochemistry of these two methyl groups, both in same plane. Both above or both below, both are identical. So both in same plane. That means the product is cis. This solid wedge indicates above the plane or below the plane. Both that we can use. Okay. So both in same plane. That is the meaning. So product is cis. Product is cis. Okay. Then another example. Another example. Fourth one. A foreign system. What is the under photochemical condition? What is the product? Product is electrocyclization takes place. You will get a 4-membered ring. 1, 2, 3, 4. Say a bond is formed between first and the fourth carbon. So the product is. So you have to explain the stereochemistry of these two methyl groups. So here the system is foreign, photochemical, dis rotation. You have to perform what type of rotation? Dis rotation. So this is the first carbon and this is the fourth carbon. Dis rotation means one clockwise, other anti-clockwise. One clockwise, other anti-clockwise. So after clockwise rotation, first CH3 below the plane. After anti-clockwise rotation, fourth CH3 is also below the plane. Okay, so clockwise rotation, this CH3 below the plane. This CH3 is also below the plane. So both are in same plane. Both are in same plane. So you can represent like this. Both are in same plane. That means the product is cis. Product is cis. So that is the method that you can predict the stereochemistry of the product. But stereochemistry of the product, whether it is cis cone rotation or dis rotation. Okay, but we have a short trick. We have a short trick without this type of rotation and any other thing. We have a short trick to predict the stereochemistry of any reaction that I will explain in the next lecture.